and I'm here with an edition of Bangor Academy with my co-host Zeppelin and Cole. Today we're going to be showing you guys how to do the 30-point problem. This is going to be on your final exam, so you're going to want to listen up if you don't know how to do this yet. The basis of the problem is finding delta G from taking delta H and subtracting the temperature times delta S. And you want to take this problem in order. You don't want to be all over the place with your numbers and equations and finding different things. Try not to drop stuff when I'm talking. Anyways. So first things first, we got to find delta S. And to do that, we got to take the reactants and the products and we got to switch them. And you have to take the number that S is represented for each of the elements in the chart that is given underneath your equation. And then you take them and you add both sides. Now, instead of reactants and products, it's products added and reactants added. And then once you get those two numbers, you're going to want to subtract them. And when you subtract them, that's going to be your delta S. And then you take that number and you're going to want to divide it by 1,000. And that's going to turn it from joules over moles Kelvin and turn it into kilojoules over moles Kelvin. And that is your delta S. Zeppelin's going to come and explain how to find delta H.
Alright guys, apart from what Cole said, I am here to talk about delta H the long way. Now see, what you got to do is you got to get your original equation, which is C5H12 plus O8O2 yields to 5CO2 plus 6H2O. Now see, what you got to do with that, you got to, get them all and break them all apart like we got here. In this right here. It's already given to you, so you guys don't have to worry about that. Don't stress out too much about it. And what you got to do is, once you break them up, you got to get their delta H numbers all good and nice. Like, once you get it, like say you have negative 393.5, then because that's CO2, you got to multiply it by 5 because of the big coefficient right in front of the equation. Then, after you got all that done, you add those all together. And then you try to get your original equation back by, canceling out things that are on the other side that are the same. Then once you add that up, your delta H is going to be negative 3314.57 kilojoules over moles. It's always going to be kilojoules over moles. Remember that. And then once you get that, you can put it into the rest of your delta G equation. Here's Cole with more.
Alright, now the third and final step that we have to do before we can plug all our numbers into the delta G equation is finding T. And T is for temperature, and it's pretty much the easiest one to find out of the whole group. All you have to do is take the temperature that's given in the problem. So for this one, it's going to be 22 degrees Celsius. So you take 22 degrees Celsius and you add 273. Remember that number, count that number in your sleep, and print it in your mind. Don't call everything 273. Yo, 273, what's up?
What's up, 273?
What book number is this?
That looks like 273.
273. Remember that number, don't forget it. Because all you have to do is add 273 to the temperature given, 22 degrees Celsius, and that equals 295 Kelvin. Make sure it's in Kelvin. And that's it. That's temperature. Now we can take all the numbers we have and plug them into our delta G equation and find delta G, which, when it's done so correctly, should give us the number negative 3,400 kilojoules over mole, and this means that the reaction is spontaneous.
I'd say that was pretty good. Pretty good explanation right there, Cole. Good job. And
that's a 30-point problem. Hopefully it'll help you guys out on your exam and get you those 30 points. It's a huge part. You know how to do this. You need to learn how to do it, because take it from me, you're going to want to know this stuff.
Yeah. Alright, click the like and subscribe, and thanks for watching.
It's been Bangor Academy.